Welcome to Azhar Microprocessor Simulator tutorial. When you open the simulator, this entry screen will be appeared. Here, you can exit the program, run simulator, or open a tutorial in HTML format. We will choose Run Simulator. This is our simulator main screen. In the middle here, the edit area, where you can add your assembly code to simulate it. On the right here, you can find a list of all instructions and their forms that you can execute in our microprocessor. When you choose any instruction, a brief description appears up there, and you can click Add to Code to add corresponding instruction to the code area here. And of course you need to change RD and RS to your desired ones. You can also notice that when cursor on a line which contains an instruction, a detailed description appears down here on Help tab. This help describes the instruction and its forms and provides how the flags affected by this instruction, in addition to examples for it. Up there, you can find the traditional toolbar, which contains New File, Open File, and Save, in addition to the search, which search for a text into the edit area. There are also our three modes: Edit mode, which we are in right now, also Simulation mode and Visualization mode, which we will explain next. There is also Add Device, which allows you to attach device to the microprocessor on a specific port and let you use in and out instructions to interact with that device, and that provides a great extendability and reliability to the simulation mode. You just need to choose the port from here, and we have here 256 available ports. Then you choose the device that you want to attach from here. We have here only 4 devices, and we are going to add more in further development. And at last, click Add Device, and it will be added here to the list of all attached devices. You also can release the device attached to a specific port by choosing the device from the list and click Release Port. It must be noted that when you use out instruction on a port which doesn't contain attached device, it will output the data on the console here. And when you use any instruction, it will show input box for the user to get data from him. There is also examples where you can find ready to simulate examples. You must remember that these 3 featured examples contain devices, and when you click the corresponding book icon, it will load the example and attach its device on port 1. But if you choose the example from the list down here and clicked Open Example, it won't add its device, and you need to add it manually. And here is the HTML tutorial, which contains also the instruction set details. And at last here is About button, which contains information about the program and list of team members working on this project. There are also small buttons for commenting and uncommenting pieces of code. Here is also very useful tool, which evaluate an expression. You can write here expression like 1234 multiplied by 101001p, and p here refers to binary, plus AF21H, and H means hex, ended by 13570, which means it's in octal, and click Calculate to evaluate the expression and make the result into decimal. And you can click on the result text to send it to the converter here, which converts it to other numeric systems. And you can use this converter also to convert your own. You also can hide or show it by clicking into converter icon here. And I think that's all about edit mode. So, after you write your code and be ready, you need to click simulation mode to start the simulation. When you click simulation mode, it will assemble the code and make an error check first. So, let's make some errors and see what would happen. And when you click simulation mode, there is a window tells us that here is an error in our code and provide us with their count. And when we click OK, it will open Errors tab, which contains the list of all errors with the line number and description about the error. When we make double click on an error, it will move us to its line. So, we will remove errors and continue to the simulation mode. Now, all the things are ready. We need only to click the simulation mode to start simulation. Here are we. When we move the simulation mode, the components of the microprocessor appears, like registers, flags, program counter, stack pointer, data segment, and memories. We have two memories, code memory and data memory. Here is the control buttons for running the program. You can click Run to run the program with specific delay determined using this slider, or you can pause and click Step Forward for step-by-step execution. We will choose Run for automatic step-by-step execution. You can notice here that while running the program, any changes in the registers or flags or memory are highlighted to make easy for the user to notice these changes. You must have been noticed that this device, which is a traffic control system here, the input here to the system coming from the microprocessor. The system uses this input to reflect the lights and the counter. It must be known that the microprocessor is the one who controls how the lights and the counters work using the running program. There is also here an instruction description for current executing one. It describes what the instruction do exactly. When you click on any register here, its value will be sent to the converter and will be converted to other numeric systems, and that is the same with data memory. And when you double click on the registers here, you can enter data immediately to the register. And that's the same with the memory. And you also can change the flags on the fly. Down here, there are two tabs which we didn't mention yet. Variables tab, which provide you with information about declared variables in your code. And when you click on a variable, it will be highlighted its line in code and in memory. And that's the same with macros. We have also provided our simulator by breakpoints for debugging purpose. There is three types of breakpoints available. The regular breakpoint, which assigned to a specific line. You can add this breakpoint by setting the cursor on the specific line, then right-click and choose to add remove breakpoint. And as you have noticed that this icon appears at that line, then whenever that line going to be executed, the running of the program will be paused. Second type is the conditional breakpoint, which assign to a specific line with specific condition, and by the same way you can add it by click add conditional breakpoint. But for this, it opens this window. Here you can set your condition, which will be checked for pause the program. Comparing operands can be registers, memory locations, variables, or immediate value. And operators are equal, greater than, less than, and so on. You should notice this icon beside the line of the breakpoint, and it differs from the other by containing question mark. This breakpoint type works as following. When a line going to be executed, program checks its condition, and if the condition is true, it will be paused, else it will be continued. The last breakpoint type is the absolute conditional breakpoint. This breakpoint doesn't have a line to assign with. You just need to add condition for it, like previous. And while program run, if that condition becomes true, the execution will be paused, whatever the current line. You can view conditional and absolute conditional breakpoints and the conditions from View menu. You also can remove any breakpoint here. Last notes about absolute condition breakpoint. That when its condition meets, the breakpoint is deactivated, and this protects you from pausing all the time. And if you want to reactivate this breakpoint, you need to do it from View menu here. The last mode is the visualization mode. When you are in simulation mode, you can click on visualization icon to move into visualization mode. Here is the detailed architecture for the microprocessor appears, like data bus, address bus, the ALU, and so on. This mode let the user monitor how each instruction exactly executed on the microprocessor by viewing how the data is moved into the internal buses. You just need to click next instruction to see how the instruction going to be executed. And here is the opcode fetching. Then click next step to continue the steps of executing this instruction. Or you can check auto next instruction and auto next step to let the done automatically. And that was the end of our tutorial. Thanks, and we hope you enjoy our work. Assalamu alaikum.